In this tutorial, I'm going to show you how to create a population map, how to extract stream and watershed delineation, that is showing the catchment area of streams, because each stream has a particular watershed basin. Then also I will be showing you how to create contour from SRTM and how to smooth the contour. So that is what we'll be doing in this tutorial, and also I'll be showing you how to geocode and how to create a time mapping in this in the next tutorial. So here, the first thing I need is the population map of the state. Now you can see we have the browser panel, we have the layer panel. Now in case these two are not there, just go to your layer, rather just go to your view, go to your panels, then here you will see layer panel and browser panel to activate it. Now the next thing, what you are going to do in this case is that you are going to bring in the Excel data, because you are going to input the data into Excel, something like this. So let's look at it. These are the population data, so I'm going to use the one for yours so you can see. So if I open it, you will see how I type the data into Excel. So you see how I type the data into Excel. You can see this is the population data, the name of the local government and the population in their area. Now, but one thing is that if you want to add, I will be showing you how to add your XY data. Adding XY data in QGIS is different. Now, and the reason why I said that is that QGIS only accepts CSV format, but when you want to create your population map, there is still a way you can drag in a normal Excel format. But when you want to create your XY data, it can only accept CSV. Now, in this case, just go to where the data is. This is my own drive C. Then go to where population data is. You can see. So from here, I can just drag it in. But the first thing I'm going to do is that I'm going to right click on this, go to properties. Rather, I'm going to right click and go to attribute table, because one thing I want to do is that the names here must tally with the name on the Excel. For example, like if I save Avigio, now this, you can see the spelling of this Avigio. Suppose I started my own with small letter, or I use capital letter to write my own, and here small letter was used in typing it, it will not match, it will not even join. So now here, you know, I said Ibadan North, then /east. In this place, you can see that slash is not there, there is space. So things like that won't make it join if there is a kind of little difference or slight difference between the way the names are written here and the way it is written. It will not join. So what I'm going to do in this case is that I'm going to make sure I go to this. You can see. So you will go to Invert Selection. Just click on Invert Selection. You can see everything will be selected. Then go to this place. You will see copy. Copy selected. Then you can minimize it. Then go to Excel. You can now go to Excel. So just click on this place. Right click. Then go to. You can see. This is paste. Don't use this normal one, but use this other one. Paste. just use paste. Now I'm using Microsoft Word 2019, so I believe you can do that as well. So if I use the first page, it will be scattered, so I will highlight all this, then right click on it, then I'll go to delete. You can see, so I will also highlight all this as well. I will click on it, and I will also delete. You can see, now you can see this now. So Ibadan North is now, you can see, I will just try to correct everything. You can see northeast, I will copy it, then paste it. You can see the reason why it's like this is that you can see they are not arranged the same way. So I will also, copy Ibadan North and paste it and replace it with this one. Then I will also copy Ibadan Northeast, Northwest rather, copy, then paste it here. Then you can see Ibadan Southeast, copy, then paste it here. You can see Ibadan Southwest, copy, then paste it here. You can see Ibarapa Central is correct, Ibarapa is Ibarapa not active. You can see active, this one, you can see what they use in saving this, active instead of artist book. So I have to change it to tally with this. So I have to change it, it has to tally with that. Then I get that is correct. The other ones are correct. Ibarapa North, you can see is correct. Akinyele is correct. This is correct. Shaki East, let's see. Ara is correct. Ori Ire is correct. Let's see. Okay, it's not correct. That slash is not here, so let's change it. Now Oyo East, Oyo West, that is correct. You can see Ogoluwa, you can see how this one saved Ogoluwa. So I will just copy this, then paste it here so that the names can tally. Olorun Shogo, then Oluyole Onara, you can see these ones are correct. Kajola, Lagelu, Ogbomoso North, Ogbomoso South, then Ido and Irepo. So those ones are correct. So I believe the other ones are correct. It's saying Tesiwaju Iwajowa. So I can just click on this one, then delete. So I'm no more using it, I've corrected that, then save. Then you can close. Now after that, you can click on this to unselect the selection. Then after that, just go to that browser panel, go to your drive, see where your data is saved, go to where the population data is, just drag in that population and drag it in here. You can see. So after dragging it here, just right click on this and go to property. Then here, go to joins. You will see joins below. Just go to join. Then here you had, you can see here you select your stage population data sheet. Then here you select this name. Then here you select this. Now, but one thing I want you to know is this, just leave this. Then here select joined fields. Then here select the two. Then click OK. Now after that, go to symbology. For you to know that it has correctly joined, you can go to label, single label, then try to use it as a name. You can see this is it. So it is this one that you are going to, you can see we have one here. If you apply this one, you can see that it's not showing anything. So now this is the one you are going to use Oyo State, data sheet population. Just apply. You can see the population of each state. So that is how you know whether it has been joined or not. So let me just change this to ADM2. That is the name of the local government. You can see. Now, so here, go to symbology. Here, select on this. Then go to graduated. That is graduated column from the thickest to the slightest. So this, you can see it will appear here. Just select your population data sheet. Then after you've done that, click on equal interval. You can see, and you classify it. So just click on equal interval, so you can see. So here you can select any classes you want. So here I want to select just 3 classes. So here, this is the low population. You click on this place. This is the medium population. Then this is the high population. High populated area, you can see. So these places now, they have the highest population. You can see this thick red, followed by this light red, then followed by these other ones. So that is how to create a population data in QGIS. Then secondly, to create contour or extract stream using SRTM. That is the next thing I'm going to do, and also to create a kind of a 3D model. So let me close this. Now what I'm going to do in this is I'm going to use Qgis. So I'm going to use 3.10 because the stream extraction is not really working on 3.12, but it works in some system. So I use the 2 version of the QGIS because there are some things that might work on this one that might not work on the other version. So for example, stream extraction doesn't really work on 3.12 on my own system, but the stream extraction works perfectly on 3.10 here, on 10 on my system. But in some systems, stream extraction work in 3.12 perfectly. So I'm going to use 3.10 for the stream extraction and contour extraction. So and I'm going to be using an SRTM data for the contour extraction. So wait for it to load. So this is it. So we want to do the stream extraction. So the first thing you to do is to go to your layer to add your data. Go to add layer. Go to add raster data. So what we are using here is the SRTM data. So click on this place and go to local. Then here select SRTM 3711. Then scroll down, or rather you can go to this place and you can only select the geotiff. It will bring them out, just geotiff. Then here just select 3811. It covers the whole Nigeria. Then open. So you can see. So the next thing is add the shapefile of the state you want to extract the stream from. So here I'll be using, go to layer, add layer, then go to add vector layer. So I'm going to use the shapefile for your state that I cut from the Nigeria shapefile the other time. So I will go to tutorial. So bring in the, just go to this place and select shapefile. So select shapefiles. So yeah, we'll select your shapefile that I cut out the other time. You can see. So I can right click on it, go to properties, and just go to simple fill, then go to fill style, then select no brush. So you can bold it a little, then apply. That's it. And the next thing you do is to go to raster, then go to extraction, extract raster by mask layer, then here input the SRTM, then here just select this. Then the next thing is just select keep resolution of input raster, then here just save in a particular folder you wish to. Just say Oyo, you can say Oyo SRTM. Let's see, then run. So that's finished. So let's uncheck this SRTM because we don't need that anymore for now. So this is the SRTM of your state. So you can extract streams and contour from this. So the next thing you are going to do is you extract your stream. Now make sure you open Qgis with grass. Just type on your window here. Once you type on your window here, you will see Qgis with grass. So just type on your window and you see Qgis with grass. So just scroll down on your processing toolbox, go to grass, then scroll down, then go to raster, then scroll down and you will see r.watershed. You can see this is r.watershed. Just double click on it to open it. So you can see, so in this ones, just put this one in blank, just put this one in blank. So just put it in blank. This is the only one thing you need. So here scroll down, then in this place you can set anything you want, but as for me, let me set 1000. If I'm extracting the stream of the hostage, just let me set 1000 as the minimum size of the exterior watershed basin. Then I'll run. So you leave it to run. So once it's done, you can see finish, then close it. So once it's done, you can see. So if you zoom in, you will see this is the stream segment. You can see the stream segment. Remove all these ones, remove these ones, remove these ones. You can see this is the drainage basin. So the drainage basin now, you can do something. You can see you can right click on it, go to properties to make the drainage basin look more proper. So here just go to pseudo band color, then from pseudo band color just classify, just go to equal interval, and then here, then color ramp, just select, let's select this. You can see, So you can classify into different classes. You can see classify into different classes. So then apply. You can see each of these streams have their own, you can see, watershed basin. So now for you to be able to know the watershed basins, so what you need to do is, let's uncheck this, so let's see this. So let's uncheck this. So what you need to do is just convert these ones to polygon, R to vect. Just you will see R to vect. You can see R to vect. Just this unique stuff, to just convert it to polygon. Just run. So you just convert it to polygon. So you leave it to run. So you can see it is done. So then close. You can see each basins. You can see each basins. So this is for each basin. So let's try to see if we can try to reduce this. Let's click on this, right click, then go to properties, then let's reduce these classes to like something like 5 classes, then click on it. Then after I reduce it to that, just go to R to vector, then unique label, then area, then value, then so smooth corners of area features. So then run. So you can see these are the watershed basins. You can see these are the watershed basins for each feature. You can see the watershed basins. So that is just about the watershed basin. So this, you can see unique label for watershed basin. These are the basin. You can see that each basin has a particular stream in there. So each basin has a particular stream in there. So these are the watershed basin. And another thing you can do is, instead of using R to vector, you can also use this. You can also use vector, raster rather, then go to conversion from raster to vector. So you can also use that. Let's go to unique label basin. Then here, just run. See? So let's see if this will run. Let's see if it will run. So we are going to use this one. So that's what we are going to use. So this is from raster to vector, and they're supposed to work, but it's not. So this is not working, and they're supposed to work. So that is just about that. So these are the watershed basins. You can see these are the watershed basins for each feature. So for each feature, these are the watershed basins. So these are also there. We can also use this one. Right click on it. Then it is also called the half basin. Just go to pseudo natural color. Then let's go to equal interval to 4 classes. And see, this is also for the half basin. So you can also go to add to vector, half basin area, then smooth corner. Then run. That is for half basin. So you can also use it too. So you can see, so that can also be used. So let's just love this. So you can also decide to go for all this. That is raster tools. You can see convert this. You can see raster tools, raster terrain analysis, raster analysis. You can see it's raster analysis. Then allow that. This is file 2. So some things we use. So now let's uncheck this. So this is the stream. So this is the stream segment, and it's within on yourself, but you can see that it's still in raster format. So the next thing you do is convert from raster to line. So just go to add to vec. Now select here, select the stream segment. Then here select line. Then you can see smooth corner of features. Then run. So that is all. Just close it. You can see. So if I right click on this now, let me just change the color of the the river to blue. So let me just change it. So let me uncheck the stream segment. So you can now see the streams now. Now you can see that the streams are not really smooth. So what you do in this case is that you go to search for line smoothing. Line smoothing. You see. So just search for all. Let's say smooth line. Line smoothing. So let's see this. So in this case, you can see the vectorize. So here you use basic SIA model. Then this other one you leave them. You leave the other ones there. Run. So you use run. You can see it has finished running. So let's close. You can now see the difference between the line. You can see the difference now. You can see the difference now. So let's uncheck this. Let's uncheck this vectorize. And right click on this and go to properties. And let's give it this color blue. So you can see the difference. You can see that this is quite more smooth than that. So that is how to extract stream from SRTM. Then what I'll be showing you again is how to extract contour from this same SRTM. So that is quite straightforward. So what you do to extract contour is just go to raster, just go to extraction, then go to contour. Then here impute the SRTM, that is your SRTM. So interval between contour, you can just say 20. Then here just leave it as elevation. Then run. So it is done now. Just close it. You can now see. So if I uncheck, you can see. If I zoom in now, you can see the contours. So let me give it a color that you see very well. Just right click, go to properties, and let me give it a kind of a brown color that will look more or less like a contour line. Okay, this is it. You can see the contour. Now if you uncheck your USRTN, you can see, but one thing you will notice is that the contour is not really smooth. You can see the contour of the state. So you can also convert this one back to normal SRTN. You can see that the contour is not smooth. So to do that, just type smooth line. So just go to line smoothing. Okay, select contour. Then yes, select basic SI model. Then just run. So that is done. So you can now close it. So you can see, if you remove this contour, you can see how smooth this is. You can see. So if I right click on the smooth contour now and go to properties, so I can actually name the contours. So you can see I can actually name the contour. You can see, just select the elevation and name it. So you can see it will, everything will appear. So that is just how to create contour using this. So now also you can also, let me remove this. So you can also use this to create SRTN. So for you to use it to create SRTN, you know, at times the data can be like this, and you can also use this to create an SRTM data. So just go to interpolation, Then from interpolation, just go to TIN interpolation. So here select contour, interpolation attribute, just select elevation. So but before you do that, let's see, before you do that, the first thing you are going to do is you are going to convert this, you are going to change the coordinate to a projected coordinate. So just right click on it, go to export, save feature as, and just see this will be saved in the tutorial. Cont, then open. So just say cont, so just say cont, so it will be saved inside that. So here, in case you could not find this here, if this one is not here, just click on this place, then search for WGS UTM 33, so it will bring it out. So you will see WGS UTM zone 33 knots. So in case you couldn't find it here, so after that you click OK. So that is done. So the next thing you do is you go to this place, new project, then you select new project. So you select new project, so it will bring in a blank page again. So just go to layer, and you will now bring in the one you converted, you change the coordinate to a projected coordinate. So it's inside this tutorial, you will see cont, you can see. So this is the one I changed its coordinates back to a projected coordinate. Just bring it in and add. So let me go to layer. Let me see contour. This is an error here. So but anyway, let's try to, okay, this is another one. This is another one. Let's just go. That is another one. So let's go onto the shape. Okay. Let me see contour. No, not that one. So let me just bring in. Let me bring in the one for smooth. Okay. So let me bring in the one for smooth. Let me see. No, this is not the real data. That is not the real data. Anyway, so let me bring in the so let me just see. Okay. Let me go to raster and see. So let me just bring in the your SRTM and see. So let me just create the contour now. Raster, then this. Let me just create the contour using the SRTM. So let me just see that interval between the lines. Then let me run. So I'll create that again. So that is done. We can close it. So I will just right click on this, go to export, save feature as. Here, let me select another document. Okay, this was in document. Okay, Yeah, the other one was in document. So let me just start. Okay, so the other one was in document. So let me just go to layer, add layer, then add vector layer, then go to document where it is saved, where it was saved. This is where the data was saved. So open. So this is the data that was converted to a projected coordinate. Now for you to know, just right click and go to properties. So from your source, you will see that it's in projected coordinate already. So now go to interpolation, go to TIN, then here select elevation. Then in this place, just click on this here, you can see. Then here select structure lines, just select structure lines. Then interpolation, leave it here. Then the extent, just use canvas extent. That is the extent of the state. So here just save to file and just see on your SRT M2. You can see or your SRT M2. Then after that you run. So in case you do that, it might not run easily, so it's better you select a small portion. Just go to vector, just go to so just go to, you can go to vector and go to clipping, not even clipping, just go to vector. Let's see, not here. You can bring in the SRTM data, just bring in the SRTM data. Okay, so just bring in the SRTM data, then you go to raster, then extract, then clip raster by extent. So in this state you can select, you can just select extent on canvas. So just select a small area, so and run. Because if you select a larger area, the problem is that it will take time to run. You can see, just select this small portion, then right click on it, then right click on it, save as in here. So just see, or you just name it with anything you like, then export it as projected coordinate. Just export. In this case, so just select a small portion, go to raster extraction, then click by extent. Then you're clicking by extent, just select on this and select canvas. You can see, just select on canvas, then you can just select a small portion. Then after that you run. Then once you've run, you can check this, you can see we have a small portion now. Then after that you go to your raster and extract and go to contour. So clip 1 and everything, so the interval between the contour, just run. So once it's done, close it. You can see, so you can see the contour, you can see the contour. Now if you want to use the same contour, you want to convert it back to an SRTM, just right click on this contour here, go to export, save future as. So here, save it somewhere here, just say contour, save. Then here select, because you have to use projected coordinates before you can do that. So that's it. Then here you can uncheck this one, you can see the contour. Then the next thing is you go to interpolation, go to TIM, you just select contour, then here select elevation, then add it here, you can see. Then here select structure lines, then let's run. Then extent, just use layer extent. No, just use the layer extent of contour as this. So here let's see something like 200, or let's see something like 300. Let's see 500. Let's see something like 500. Then after that you run. So you leave it to run. So you leave it to run completely. So that's all. You can see that it's already back to its SRTM, though it's not that perfect, but it has converted back to the normal SRTM. So if something like this happens, you can still go back to TIM, select the elevation, then here add it in, then here you can select something, here select, just select, let's select the layer extent of this. Then here you can see, let's select the layer extent of the SRTM. Then let's leave this one like this. Then run. So that is how to create the to recreate back the SRTM. Now in this case we are going to create a 3D model. Now but first thing you are going to do is that you have to convert it to a projected coordinate. So export. So then you save the place where it should be. Let me save it with SSSS. Then here you change it to a projected coordinate. Then after changing to a projected coordinate, you run. So that's the first thing you do. Then after that you go back to a new project. Then you go to layer, then add, then go to add raster data. Then here you select where the data was saved. So I will go to map. This is where the map is, so you can see this is it. Then I'll bring it in. Now this is what I will use for the 3D modeling. So here I will right click on this, go to properties, then here I'll go to single band pseudo color. Then here I'll go to equal interval. I'll select equal interval, then just apply. You can see using different color. Now the next thing I will do is I will go to view. I'll now go to new 3D map view. If you haven't changed it to a projected coordinate system, it will not open this. It will only be giving you error and it will be telling you to change to a projected coordinate. You can see this is it. So now you can see that it's still in it's still not yet in 3D. You can see it's still in 2D. So you can use the middle of your mouse to pan to change the direction. You can see, use the middle of your mouse to pan. So if you view it, you can see that it's still not in 3D. You can see it's still not in 3D. So the next thing you do is that you go to your settings here. You can see settings, configure, then field of view 45 degree, then here flat terrain, change it to DEM, then elevation, change it to that data, then vertical scale, increase this one to like 20, then after that click OK. You can see, so once you've done that, you can see the elevation, so you can see that is the elevation. So that is how to view it in 3D. But if you actually want to create 3D of all this elevation, it's better for you to pick points on Google Earth and create it in SOA. But this is how to view 3D view in QGIS. This is it. So the next tutorial, we are going to look at time mapping, geocoding, and geocoding, as well as image classification using QGIS in the next tutorial.